Two hollow spheres with radii r1 and r2 respectively contain same quantity of air at same temperature. Find the ratios of the pressure in the spheres. This is a diagram that shows two spheres described in the questions, where we call this as sphere number 1. This is a sphere number 2. So for this sphere number 1, the temperature is T1, and the sphere number 2 temperature is T2, but it is equal to T1, same temperature. For the masses of the gas in the spheres, M1 and M2, they are also the same. Now the size of the sphere given by this radius R1 and R2, we do not know which ones is bigger because it is not mentioned in the questions. So we are not sure whether it's R1 bigger than R2 or R2 bigger than R1. But the question asks us to find out what is the P1 and P2, the ratio of P1 and P2. We want to find the ratio between P1 and P2. P1 and P2 are the pressure. So now we start from the ideal gas law, PV equal to nRT. That means we assume the air in these two spheres are ideal gas. That obeys the equation of state, PV equal to nRT. So V, the formula is 4/3 pi r cube. This is the volumes for the sphere, which is the volumes of the gas. So by writing this V in terms of as the 4/3 pi r cube, then we are introducing the radius R1 and R2 of the spheres into these equations. And this n, number of mole, it is m/m. So that means we also introduce the masses of the gas into these equations by substituting the n equal to m/m, where the capital M is the molar mass of the gas, which are the same for the gases in these two spheres. Now we can, based on these equations, to write down two equations 1 and 2 for the two systems of gas in the two spheres. Now if you look at these two equations, you can see that the P, R, M, and M, we put the subscript 1 for the sphere number gas number 1, system of gas in the sphere number 1, and we have this P2, P, R, M, and T have the subscript 2 for the system of gas in the system for the system of gas in the sphere number 2. For the others quantity, let's say molar mass of the gas, the gas constant and the pi, we don't put a subscript because these three, obviously we can cancel them out because they are the same. Now if we take equations 2 divide by equation number 1, then 4/3 pi will be cancelled out. The molar mass M will be cancelled out. The gas constant R also will be cancelled out. So therefore we will have at the left hand side, it is equal to, we will get P1 R1 cube divided by P2 R2 cube. And at the right hand side of the equality sign, we will get M1 T1 divided by M2 T2. Since the temperature of the two gases, they are the same, where T1 equal to T2, and also their masses also the same, which is the M1 equal to M2. Therefore, at the right hand side of the equality sign of these equations, we will get 1. Therefore, P1 over P2 will be equal to R2 cube divided by R1 cube. If we bring this R1 cube over R2 cube to the right hand side, we will get R2 cube over R1 cube. This is the ratios of the pressures for the gases in the two spheres. From the result we obtain, we can see that the pressure of the gas is inversely proportional to the R cubes, the radius of the sphere. So that means if you want to have the higher pressure of the gas in the sphere, then we have to prepare a sphere which has a smaller radius. Similarly, if we want to have the smaller pressure of the gas in the sphere, then we need to prepare a sphere with the larger radius. So although the questions never mentions R1 bigger or R2 bigger, but we can know that what is the relationship between the pressure and the R.